Okay.
The next, the report, Вдовиченко, Вячеслав Харченко, Артем Перепелицын, Fault-tolerant
Fault-tolerant
Microcontroller.
microcontroller chip.
He
with
said, yes.
Yes, thank you. Greetings to our honored audience. We are pleasure to welcome you at our conference. My name is Alexander, and today we are glad to present you a report about fault-tolerant microcontroller chip with controlled degradation. In context of our presentation, we will motivate our research, set its goals and objectives. On the next step, we will observe existing fault models and make our own classification based on defects and their consequences. And then we will describe and simulate a model of behavior targeting on existing hardware solution. So let's start. In modern world, digital computing system became closely related with a significant part of human activity, including space, deep dive areas, dangerous polluted zones, and etc. For such areas, embedded and real-time systems with high reliability requirements are necessary. But in traditional approaches for increasing dependability parameters can be difficult to apply in such conditions. Therefore, it's need to find a way to improve reliability of such systems with minimal impact of their hardware on their hardware. So, for increasing the availability of computer systems, system components by implementing the process of remote reconfiguration, we should to follow next tasks. Analyze and perform a classification of possible failure and recovery states, propose a model for reconfiguring such systems for failure recovery, provide a practical example of how to apply the model of a specific system. According to described tasks, following failure models were observed. The main difference that should be noticed is an object of view. Each model focuses on single point of error occurring process, like cause, consequence, fatal rate, or time influence. Following such method of failure modeling, we described our own model based on defects and their reconfigurability. We highlighted such defects that have a partial or temporary influence and defects with fatal consequences. Also, there were, if we regroup defects according to their reconfigurability, we can see the same way as in sides of non-fatal and fatal cases. If we merge those two groups of defects, we can highlight a group of defects that can be mitigated with using reconfiguration procedure. So, to define a way of application for described above, we offer to simulate a behavior model with next restrictions. There are an absolute reliability of diagnostic system, exception of consequent chain effects, and instant response. Model can switch between following states. There are already familiar upstate, fault, and error states. Also, we can notice such states like degradation and reconfiguration abilities fading. For start conditions, an IEEE 13A microcontroller was chosen. It has port B, which consists of 4 similar pins that can be used in reconfiguration procedure. Their similarity led us to redistribute the working load between working pins in case when one pin fails. with minimal count in 2 pins for productive work. This operation can be performed twicely. The state with fallen pins you can see marked as SD, that can be a starting point for controlled degradation to the next restructured but stable up states. In such way, our system can progressively switch up states more and more times till reconfiguration limits are reached. But in another direction, we should describe a degradation of reconfigurative means. In this case, we gradually lose the ability to parry emerging errors which are suitable for reconfiguration. Using the values of reliability parameters of the base system components, the controller operation was simulated in 2 modes: reconfigurable or multi-fragmented mode, later MFM, and non-reconfigurable or ordinary fragment mode, or OFM, later. On first thousands of hours, MFM showed increment of uptime rate in comparison with OFM. This trend continued into the subsequent millions of operational hours, which shows the correctness of the model's performance. So, in conclusion, we need to highlight that we observed existing failure models. We described our own models based on defects and their consequences. We described a state model and chose the real hardware for simulation of behavior to that model. And we show the results that can be used later in our work. Thank you for your attention. If you have any questions, please ask.
Thank you for your report. Very interesting. Any questions? Because I have a question too. No, I have a question about application of your research. The main application in simulator or in real situation, where application?
If you mean application that's shown in presentation, it
your investigation, your results, where application may
be used.
Да, may be used.
May be used later in developing our model. If you saw presentation well, you can saw that we used some restrictions for model, and later we need to deny some of them to be closer to natural, real systems that we can apply our methods in hardware representation, I guess.
Let me add a few examples like a cursor to clarify the area of possible applications. We analyzed in this research that the intensity of faults for microcontrollers in times less than intensity of possible faults of PCB, printed circuit board. And in some environments, it's possible to obtain some maybe broken connections or maybe some short circuit and because of that, the entire system can stop the working. And to prevent such situation, we decided to organize the entire life cycle of such solutions to enable some degradation in functions, but with saving the workability. It means that even after losing of few lines on the printed board, if it's not the power lines, for example, it's possible to predict such situation, create such option of reconfiguration and even automatic reconfiguration. And in this way, it's possible to save the workability of the device. And it can be applied everywhere where the such microcontrollers are applied. But first of all, we consider non-critical applications. But the application of such results to critical area is also possible, but requires additional research.